Hello everybody and welcome back to the Java tutorials. It's been a little bit since I've done the last video, but today we're going to be talking about a little, I guess, kind of a more computer science or more memory oriented concept today, and that's the Java's distinction between primitive and reference data types. So I believe I referenced, or I think I talked about what primitive types were. So you have your int, char, byte, short, long, float, double, and boolean. And in Java, these values are only, you only store the values. So, for example, if we had an integer a is equal to 5, and we said then integer b is equal to a, and I went and printed out both of them, what would happen is, let me just run this, I just get 5 and 5. Now let me try modifying one of them. A is equal to 6 now. Let's see what happens. A becomes 6, but B remains at 5. This is because primitive types, if you assign something, it makes a copy of the value. So in the memory, what happens is A, here, let me just do this, and I'll also zoom in here. A is stored as 5 in memory. I think that's the best way to represent it, but think about this box here with the 5 of it has some address in memory. We can call it 0x100, doesn't matter. Now when I say B is equal to A, so just int a equals 5, then int b is equal to a. What happens now is it creates a new slot of memory, but only copies the value. So 5, and it's 0x100, or 0x104, I'll say. Yeah, so that's primitive types, and this works for all of those, so double, boolean, whatever. Now let's look at reference types. So reference types refer to objects, specifically objects, so anything that has a class. So let's go ahead and create just a very basic class with a name. So I'm going to say above the episode 8 code here, I'm going to declare another class, and you can do this as long as it's not public. So class, and let's say ball, and in here we just have string color, just like that. So now let's look at this here. So let's say ball b1 is equal to new ball, and b1.name is equal to ball1, or b1.color, sorry, is equal to red. Just like that. So if we were to print it out, we would get red, obviously. Now let's create another ball. So ball b2 is equal to b1, and then we'll print out both of these. So let's say b1.name and then b2.name, or not name, color. And then let's go ahead and run it. We get red and red. Now that's what we expected, right? Because you're essentially copying stuff over when you assign it to b2. Now let's try and modify something. So let's say b1.name is equal to, or b1.color is equal to blue, and then let's print out the colors again, and you'll see something happen here. They're both blue now. So what does this mean? Well, in Java, everything works with pointers. So if you're coming from C++, you'll know about what pointers are. But essentially, when I call color, or goddammit, when I say ball b1 is equal to new ball, what this does is it allocates some sort of memory. So b1 now points to some slot in memory that has enough memory to contain everything for a ball object, and we just have the color here. And it turns out that color is a string, and string is another object. String is not a primitive. So this points to another object, just like that. Now when I say ball B2 is equal to B1, what happens is B2, and in Java, if you represent an object, all it sees is just references or locations of data. So let's say this was at 0x, let's see, 109, something like that. What the program sees is that B1, the value of B1 is 0x109. So B1 is 0x109. And that in memory points to an object of type ball. And then there's a string in there. Now when we initialize B2, what happens is we are still copying something over, except we're copying over an address value. So B2 now has 0x109 as well, so therefore it points to the same object. So they both point to the same object. So when I modify, when I say, let me write this in a different color. So B2 or B1 dot color is equal to blue. So if it's equal to blue here, what happens is I update this pointer over here. So it turns out with strings that if you change it, this allocates a new string. So this will now point to blue. Wait, I should say red, but you know what? Because I wrote it in red, you got, yeah, okay, whatever, yeah, just deal with it. So yeah, that's how that works. Now let's I'll make it easier to look at in the diagram. Let's make it have an integer. So we'll say int color or int radius, or let's say double. So this time b1 dot radius is equal to 5.0. Then b2 is equal to b1. So then b1 dot radius is equal to 6.0. I'll say b2 dot radius actually, just to show you how it works both ways. So you get 5 and then 6. That's right. So now let's redraw this diagram. So remember, ball b1 is equal to new ball. That allocates some memory. So B1 now has a value of, let's say, 0x115. And then this points to the location memory at 0x115. And it is a ball object. And in here we just have a double for the radius. And it's initialized as its default, so doubles have an initial or a default value of 0. So this is the ball object in essence. Now when I say, now I say ball b2, or let me change colors. So ball b2 is equal to b1. Once again, we copy over the reference or the address, so b2. Oops. God damn it. So they both point to 0x115, and if you don't know, 0x is hexadecimal. So that's just typically how you represent addresses in memory. So they both point to the same object. Now we say b2 dot, or what do we say? B1 dot radius. Oh, I need to drag this down just because I forgot to set up the initial radius. So b1 dot radius is equal to 5.0. So now since it's a primitive type, this doesn't point to anything. So we don't allocate anything new. We simply overwrite the memory. So it becomes, I need to make this bigger. 1 second. This now says 5.0. All right. So now they're both pointing at the same thing. So when I say print b1.radius and b2.radius, they both print 5.0. Now, when I say, let's say in green now, b2.radius is equal to 6.0, what happens is it looks to wherever b2 is pointing, and it's the same ball object, so it just overwrites the value with 6.0. So now when I print out b1.radius and b2.radius, they still print out the same exact value. So yeah, that's essentially reference types versus primitive types. Just a quick recap. Objects, anything that has a class is a reference type, so it's represented as addresses in memory, or that's how Java interprets them, and they point to stuff. And if you modify anything that it points to, it changes that the reference, or not the reference, it changes what the reference is to, and everything else that's pointing to that will also see the same change. Now, if I were to do something like, say, before the b2.radius, let's say b2 is equal to new ball, what would happen is you get a 5 and a 6. So b1 is 5 and b2 is 6. So let's see what happens here now. So let's say, let's do this in purple. So b2 is equal to new ball. What happens is this value here is destroyed. This reference here is destroyed. Or the address, the value of b2 is destroyed, and it's replaced with whatever the next one is. So we create a new ball, and the radius is 0.0, and let's say it's at 0x 150. So now b2 has a value of 0x 150. So you can kind of think of addresses as primitive data types, but you cannot access them. There's no like address type in Java. Yep, so the new ball. Then when we say b2.radius, or let me change colors, I'll go in gray now. b2.radius is equal to 7.0. What happens is it only changes the reference at 0x150. So this becomes 7.0, but b1, the reference at b1 is left unchanged. So once again, that points there. And so the new, whenever you use the new keyword, you are creating a new reference, so it points to a different location in memory. Yeah, so that's primitive types and reference types in Java.